Hello, boys and girls. Welcome to the Ministry of Education and Partners COVID-19 Teaching by Radio program. The Ministry of Education and Partners COVID-19 Teaching by Radio program is a 30-minute radio intervention support program that is meant to provide continuous instruction to keep you academically engaged during this stay-at-home period, as well as preparing you, our 6th, 9th, and 12th graders for the pending Liberia Primary School Certificate Exam, Liberia Junior High School Certificate Exam, and West Africa Senior Secondary Certificate Exam when the time comes. Also, in addition to this academic support, the program is meant to provide psychosocial support for learners, teachers, and parents, and also tips on how you as parents and teachers can provide support to your students and children at home. Now, let's join our teacher for today's lesson.
Hello, learners, parents, and teachers. I am Julia K. Sandiman, your radio teacher for this lesson. And this is the Ministry of Education and Partners COVID-19 Teaching by Radio program for you, our beloved learners, parents, and teachers of the Republic of Liberia. Welcome. Our subject today is General Science for students of grade 9, and the topic is energy and machines, motion, speed, velocity, acceleration. Please take a pencil, pen, and copybook and get ready for today's lesson. Again, the subject is General Science for students of grade 9, and the topic is energy and machines, motion, speed, velocity, acceleration. Again, welcome and let's learn. The objective of our lesson is to help us learn how to calculate speed, give the difference between vector and scalar quantities, and calculate acceleration. Learners, we are going to learn how to calculate speed, understand the difference between vector and scalar quantities, and also calculate acceleration. By the end of this lesson today, we will be able to calculate speed, understand the difference between vector and scalar quantities, and calculate acceleration. Now, listen as I read, but I want you to pick up your copybook, pencil, or pen and get ready to write also as I read. Are you ready? Good. John J. can run 30 meters in 5 seconds. John J. can run 30 meters in 5 seconds. And Sir can run 42 meters in 6 seconds. Who is faster? John J. can run 30 meters in 5 seconds. And Sir can run 42 meters in 6 seconds. Who is faster? If you want to know the answer, you need to be able to calculate their speed. Speed is a measure of how far someone or an object can travel in a fixed time. Speed is a measure of how far someone or an object can travel in a fixed time. This can be either per second or per hour. To calculate speed, you divide the distance traveled by the time taken. To calculate speed, you divide the distance traveled by the time taken. So speed is equal to distance over time. The units we use are meter per second or kilometers per second per hour or miles per hour. Again, the units we use are meter per second, kilometers per hour, or miles per hour. The units we use are meter per second, kilometers per hour, or miles per hour. Now learners, let's calculate John Jay and Sar's speed to see who is faster. Remember, to calculate the speed, you have to divide the distance traveled by the time taken. Again, remember, to calculate the speed, you have to divide the distance traveled by the time taken. John Jay ran 30 meters in 5 seconds. So we will divide 30 by 5. We will divide 30 by 5. When you divide 30 by 5, your answer is 6. So John Jay's speed is 6 meters per second. John Jay's speed is 6 meters per second. Sar ran 42 meters in 6 seconds. Sar ran 42 meters in 6 seconds. So we divide 42 by 6. Sar's speed is 7 meters per second. Learners, who is faster? Yes, Sar is faster. He ran 7 meters per second, while John Jay ran only 6 meters per second. Remember, to calculate the speed, you have to divide the distance traveled by the time taken. To calculate the speed, you have to divide the distance traveled by the time taken. We will take a short break and bring you some health tips. And when we get back, we will go right into the discussion on vector and scalar quantities. Remember, this is general science for students of grade 9. And the topic is energy and machines. Motion, speed, velocity, acceleration.
Coronavirus is spread via droplets. When the person coughs or sneezes, the droplets land on surfaces and are picked up on the hands of others and spread further. People catch the virus when they touch their infected hands to their mouth, nose, or eyes. It follows that the single most important thing you can do to protect yourself is keep your hands clean by washing them frequently with soap and water or hand sanitizer.
Welcome, learners. Now that we know how to calculate speed, we are going to talk about vectors and scalar quantities. Velocity is speed with direction. Velocity is a vector quantity and speed is a scalar quantity. Velocity is a vector quantity and speed is a scalar quantity. Scalar quantities have size or magnitude only. Scalar quantities have size or magnitude only. For example, temperature, mass, or distance. For example, temperature, mass, or distance. Vector quantities have both magnitude and direction. Vector quantities have both magnitude and direction. For example, velocity, or forces and acceleration. Velocity, all forces and acceleration. So learners, the difference between vector and scalar quantities are vector quantities have both magnitude and direction, and scalar quantities have only magnitude. The difference between vector and scalar quantities are vector quantities have both magnitude, and direction. Why scalar quantities have only magnitude. The difference between vector and scalar quantities are vector quantities have both magnitude and direction, while scalar quantities have only magnitude. Now, we are going to learn how to calculate acceleration. We are now going to learn how to calculate acceleration. We have learned how to calculate speed. We now know the difference between vector and scalar quantities. We are now going to learn how to calculate acceleration. If you are running along a path and then you speed up, you have accelerated. If you are running along a path and then you speed up, you have accelerated. This means your speed has increased. To work out acceleration, you need to use the following formula. To work out acceleration, you need to use the formula below. Acceleration is equal to change in velocity over time taken for the change. Acceleration is equal to change in velocity divided by time taken for the change. The units are meters per second, meters per second squared. Learners, let's take an example. Are you ready to write down the example? Pick up your pencil or pen and let's write down the example. A bicycle and a car start their journey at the same time. A bicycle and a car start their journey at the same time. The cyclist reaches a speed of 10 meters per second in 1 second. The cyclist reaches a speed of 10 meters per second in 1 second. The car reaches a speed of 50 meters per second in 5 seconds. Which has the greatest acceleration, the car or the bicycle? Again, a bicycle and a car start their journey at the same time. The cyclist reaches a speed of 10 meters per second in 1 second. The car reaches a speed of 50 meters per second in 5 seconds. Which has the greatest acceleration, the car or the bicycle? While you work on this, let's take a short break and bring you some health tips. And when we get back, we will continue with our lesson.
What are the symptoms of COVID-19? COVID-19 symptoms include cough, fever, shortness of breath. In rare cases, COVID-19 can lead to severe respiratory problem, kidney failure, or death. If you have a fever or any kind of respiratory difficulty, such as coughing and shortness of breath, call your doctor.
Welcome, and let's answer our question. Now, learners, let's calculate and see the car and bicycle which has the greatest acceleration. Remember, acceleration is equal to change in velocity divided by time taken for the change. Remember, acceleration is equal to change in velocity divided by time taken for the change. The bicycle accelerates 10 meters per second in 1 second. So, we will divide 10 by 1. Therefore, the bicycle accelerates 10 meters per second squared. The bicycle accelerates 10 meters per second in 1 second. So we will divide 10 by 1. And when you divide 10 by 1, your answer is 10. So therefore, the bicycle accelerates 10 meters per second squared. The car accelerates 50 meters per second in 5 seconds. So we divide 15 by 5. If you divide 15 by 5, your answer will be 3. So therefore, the car accelerates 3 meters per second squared. The car accelerates 50 meters per second in 5 seconds. So we divide 15 by 5. The car will therefore accelerate 3 meters per second squared. Learners, which has the greatest acceleration? Yes, the bicycle has the greatest acceleration. It accelerates 10 meters per second squared, while the car accelerates only 3 meters per second squared. Learners, today we learn how to calculate speed and acceleration. We also learned the definition of speed and the difference between vector and scalar quantities. Today, we learn how to calculate speed and acceleration. We also learned the definition of speed and the difference between vector and scalar quantities, where vector quantities have both magnitude and direction, while scalar quantities have only magnitude. We also define speed as a measure of how far someone or an object can travel in a fixed time. This can be either per second or per hour. Now, learners, I want you to write down these questions so you can continue practicing how to calculate speed and acceleration. I want you to write down these questions so you can continue practicing how to calculate speed and acceleration. Remember all of our formula used for today. We said speed is equal to distance divided by time, and acceleration is equal to change in velocity divided by time taken for the change. Are you ready to write down your practice questions? Good. Number 1. Question number 1. An antelope can run a distance of 60 meters in 2 seconds. An antelope can run a distance of 60 meters in 2 seconds. What is the antelope's speed? What is the antelope's speed? An antelope can run a distance of 60 meters in 2 seconds. What is the antelope's speed? Question number 2. A car accelerates from 5 meters per second to 25 meters per second in 10 seconds. A car accelerates from 5 meters per second to 25 meters per second in 10 seconds. What is the acceleration? What is the acceleration? A car accelerates from 5 meters per second to 25 meters per second in 10 seconds. What is the acceleration? Now, boys and girls, you can use the following to continue reading. You can go on YouTube or use the following websites: www.ck www.ck12.org. The next, www.khanemy.org. And the next, www.lifescience.com. www.lifescience.com. Remember to always wash your hands with soap and clean water or use sanitizer. Avoid close contact with sick people. Cover your mouth and nose with clean tissue, towel, or handkerchief when coughing or sneezing. Do not shake hands. And if you have a fever, go to the nearest clinic or hospital. Please stay safe and healthy always. In our next lesson, we will be talking about forces. So I want you to go on, read on forces. If you have any questions or need clarification on today's lesson, please text it to the following numbers: 0555 811-309, 0555-811-309, or 0886-579-678, 0886-579-678. I have been your radio teacher for this lesson. I'm Julia K. Sandiman.